All right, so we're going to talk about the unit circle. And the unit circle is a circle of radius 1. That's why it's called the unit circle. It's 1 unit. It's centered at the origin in the xy plane, and its equation is x squared plus y squared equals 1. So we talked about that in the last lesson. So we're going to talk about the points on a graph. We can actually see here is our unit circle with x squared plus y squared equal to 1 is the equation. It's centered at the origin, and our radius is 1 going out in either direction. So we're actually going to look at some points on our unit circle. So in this case, we want to actually show that a point is on the unit circle. So here is our point. It is the square root of 3 over 3 and the square root of 6 over 3. So this has to satisfy the equation of the unit circle. If we recall, our unit circle equation is x squared plus y squared is equal to 1. So we're going to plug in our values. So always remember your points are x and y. So we're going to have the square root of 3 over 3 squared plus the square root of 6 over 3 squared. And we want to know if it's equal to 1. If we get a true statement, it's on the unit circle. If it's a false statement, it won't be. Well, the square root of 3 squared, that's the square root of 3 times the square root of 3, will get us 3. And 3 squared will get us 9. Square root of 6 squared, we're squaring that square root again, so it's just going to get us 6, and 3 squared is 9. We still want to know if it's equal to 1. Well, 3 plus 6 will get us 9 over 9, and 9 over 9 is 1. 1 is equal to 1, so we can say, yes, this is a point on the unit circle. Let's do another example. So if we have -5/7 and -2 square roots of 7, we want to know if it's on the unit circle as well. So again, this is our x and our y, and we're plugging it into x squared plus y squared is equal to 1. So we have -5 over 7 squared plus -2 square roots of 6 over 7 squared, wanting to know if it's equal to 1. Remember, anything that's negative that's squared is going to get us a positive. So -5 squared, -5 times -5 will get us 25. 7 squared is 49. Plus -2 squared will get us positive 4, and the square root of 6 squared, just like we saw earlier, is going to get us 6, all over 7 squared, which is 49. Well, we need to multiply 4 times 6, so we have 25 over 49, plus 4 times 6 is 24 over 49. Well, 25 plus 24 would get us 49 over 49, so 1 is equal to 1. So again, that point is on our unit circle. So the next thing we're going to look at is locating a point on the unit circle. So we're going to locate a point on the unit circle. So we are given the square root of 3 over 2, comma y, and we're told that it's on the unit circle, so I'm going to just put UC, unit circle, and we're told that it is in quadrant 4. So remember, with quadrant 4, we're looking at our unit circle. Up here, let's talk about this, what this means for signs. That's what the quadrant will tell you is what the signs are. If this is our unit circle here, and this is the x-axis, and this is the y-axis, up here in the x-axis, everything will be positive because we have positive x and positive y. If we look at quadrant 2, in quadrant 2, our y's are positive and our x's are negative. In quadrant 3, both the x and the y are negative values because they're both on the negative side of the x and the negative part of the y. And then in quadrant 4, our x will be positive, our y will be negative. So when we're looking at this, we know that our x is positive. Our y we know will be negative because it's in quadrant 4, because that's where our x and y axes have values. So we need to find the y coordinate. So we're going to again use our unit circle. So equations, we have x squared plus y squared, again, is equal to 1. So we have the square root of 3 over 2 squared plus y squared is equal to 1. Square root of 3 squared would get us 3. 2 squared is 4 plus y squared is equal to 1. We're going to subtract our 3/4 to the other side. And we get y squared is equal to 1/4. We can change this to a common denominator in order to subtract it. So 4 minus 3 gets you 1, and 4 will stay on the bottom. So now when we take the square root, remember using our square root properties that we know that this ends up being plus or minus. So this is the plus or minus the square root of 1/4. Well, these are actually both perfect squares. We can, remember, we can separate this out to be the square root of 1 over the square root of 4. So then it's still plus or minus. Square root of 1 would be 1. Square root of 4 would be 2. So we now have y is equal to plus or minus 1 over 2. So which is it? Is it positive 1/2 or negative 1/2? And that's why we need to know the quadrant. In quadrant 4, we know that y is negative. So we know that y will be equal to negative 1/2, and our point on the unit circle would be the square root of 3 over 2, negative 1/2. And that would be your point. This would be your answer for y, and that would be the point on the unit circle. Alrighty, so let's go do another one. So for our next one, we're doing the same kind of thing. We are given a point. This time we're going to call it point P. It doesn't matter, it's just still a point. The point of x comma negative 7 over 25. And again, this one's going to be in quadrant 4. So in quadrant 4, this is correct, that our y is negative, our x value will be positive. So let's go find what that x is. We're doing the same equation. X squared plus y squared is equal to 1. So we'll have x squared plus we'll have negative 7 over 25 squared is equal to 1. That gets us x squared. Negative 7 squared is 49. 25 squared is 625. We'll now subtract this from the other side. So we now have x squared is equal to, and again, you can change this to a common denominator. And when we subtract that, we're going to get 576 over 625. Again, we will take the square root of both sides. So we get x is equal to plus or minus. Now we can take it all down there, but these again are going to be perfect squares. The square root of 576, and we can break it down to this. We can break it down. The square root of 576 will get us 24, and the square root of 625 would be 25. So, is it positive or negative? Well, in quadrant 4, our x is positive, so x will be equal to 24 over 25. And our point would be 24 over 25, comma, negative 7, 25. So that would be the point that lands on the unit circle. All right, so the next thing that we're going to look at is the terminal points. And the terminal point is exactly what it's talking about. Where do the points stop? And I know the graphs don't always come out very well, so let's move this down just a little bit and hope. Turn off the light. There we go. We'll put it under the shading, maybe you can see. So on this point here, we are looking at where the point stops. And if you can see, the point stops here. So this is, the terminal point is landing here. The terminal point is landing here. Here, our terminal point is landing at the top. Here, it's landing clear over here. We've got one that comes clear around. And we can have one that goes completely around. So we're looking at our terminal points. Sometimes I wish the graphs would come out better in copies, but they just don't always cooperate. But I'll draw some out for you. So if we're looking at our terminal point, the big thing that we're looking at is whether or not our t is greater than 0. So for the terminal point, if we're looking that t is greater than 0, which means it's positive, we are always going to start at 1, 0. That's just how it's always going to start, at the terminal point. You can look at our picture here of our unit circle. It always starts here at 1, 0, at the x-axis at that unit circle. So it's going to start here, and our t's will go this way, or if they're positive, it's always going to go this way. If it's negative, it will go this way. So if we're looking at something that's positive, and the t is the distance. So here it's going to go counterclockwise. If our t is less than 0, which means it's negative, then it will go clockwise. And it will still start at that same point. All right, so if we're looking at a positive one, and we have a unit circle, that means that it's going to go counterclockwise. So if we have a point over here, this would be the way it goes. And this would be a point on the unit circle of x, y. On the less than 0, we draw another unit circle. And let's say our point lands here, it would go this way. This would still be a point of x, y. Now, in this case, our y we know will be negative here, and our x would be negative up here, but it's still a point in whatever your x and y values are. So let's find our let's find some terminal points. Let's talk about some circumferences that happen at the unit circle. All right. So what you need to remember is that the circumference of the unit circle is c is equal to 2 pi r, right? But our radius is 1. So we're looking at 2 pi times 1, which would be 2 pi. So on our case, our unit circle, it's always going to be 2 pi around. We're always going to start at that point, and we're going to go 2 pi. So if we look at the unit circle, and we're always going to start at this point here, which is 1, comma 0. It's 0 because it's on the x-axis, moved over 1 from the radius, and then it's 0 because it's also an x-intercept. And we can travel clear around 2 pi. So we're going to start here, and we're just going to move around. We can go around 2 pi. Now, if we want to go halfway, if we go halfway around our circle, again, we're going to start over here. And if we go halfway, let's do this. We're going to come all the way over here. What would that point be? Well, that point is still on the x-axis, but now it's on the negative side of x. It's still a radius of 1, so it will be negative 1 for the x. It's still an x-intercept, so it's negative 1, 0. And what is the distance that we go? Well, since we went halfway around, it's 1/2 times our 2 pi. You can always put that 2 pi over 1. The 2's would cancel, and we end up with pi. So halfway around our circle is pi. Now, if we want to go, let's say, 1/4 of the way around our circle. Let's go 1/4. Because if we're looking at it, it's broke up into 4 quadrants, which means it's 1/4 of it. So 1/4 of our distance, we would have 1/4 times 2 pi. And again, you can always put that over 1 to see how it goes. That ends up with 2 pi over 4, which would reduce down to be pi over 2. Now, 1/4 of the way around, we're looking at our unit circle again. That means we're starting here, and we're going up to this point right here at the very top. We're landing on the y-axis. So what would the point be there? Well, if we're on the y-axis, that is a y-intercept. So x value is 0, our radius is 1, so it's 0, 1. Now we can also go 3/4 around. The distance we'll travel will be 3/4 times 2 pi. Again, we can put that over 1. And that'll be 3 times 2 would be 6 pi over 4. It reduces down to be 3 pi over 2, or 3/2 of a pi. So again, where does that land us? So here's our unit circle. We're starting from here. We're going to go 3/4. This is 1/4, 2/4, 3/4. So we're going to go 3/4 of the way around. And this point, again, is on the x-axis. So we are looking at, it's on the y-axis. And so our x value is 0 still, and we're still 1 away, but because we're down here, the y values are negative, so it'll be 0, negative 1. So basically, those quarters get us all the way around to our intercepts. All right, so let's go find some other points on our unit circle. We're going to find the terminal point, determined by each of our numbers of t. So again, we're find the terminal point. So we're going to use the same process we've used already. So if we're looking at t is equal to 3 pi, we draw our unit circle here. And if we're looking at 3 pi, well, we know that this would be 1 pi, 2 pi. 2 pi is all the way around. It's 1 more pi, so it's going to then land us back over here. So the terminal point would be negative 1, 0, because we're back over here on this x-intercept. All right, let's look at t is equal to negative pi. So if we're looking at negative pi, we'll draw our unit circle again. Remember, if t is less than 0, we go clockwise. So again, we start here. We're going to go 1 pi this way. And what is our point? Well, it's the same point we just had. It's negative 1, 0. So you can get the same point going different ways. You can have a lot of your t's be the exact same point. All right, let's look at another one. What about t is equal to negative pi over 2? Well, again, we're going to draw our unit circle. And we're going to start at the same point. This time we're going to go half a pi. So if a whole pi is here, this is our half a pi. And we go this direction because it is negative. And we know that this point is a y-intercept. It's 0, negative 1. So now let's talk about what a terminal point could be if we're looking at determined by t is equal to pi over 4. Now, pi over 4, that's going to be 1/4 of a pi. So if we draw a circle, one-fourth of a pi, that means it's half of this half. So we're going to land about right here. This would be pi over 4. Now we haven't figured out what those values are, but we can use some knowledge that we have. So if we're 1/4 of the way and we're in quadrant 1, we are going to understand a couple of things. First of all, if we're landing at this, then our halfway up, our x and our y value will be equal to each other. So because it's going to be the same distance here as it would be here. From 1, 0 to 0, 1, it's the same distance along the unit circle. And so we can understand that there is a line right here that y is equal to x. And so because they're the same distance, they will be equal to each other. Now we know from our earlier discussions that x squared plus y squared is equal to 1. So if y is equal to x, then we have x squared plus x squared equals to 1. Well, when we add those, we get 2x squared is equal to 1. We can divide by 2, and x squared would be equal to 1/2. Taking the square root of both of those, we would get x is equal to plus or minus the square root of 1/2. Now, like we've done before, we know we're in quadrant 1, so we know it will be a positive value because we're in quadrant 1. Both x and y will be positive. So we know it'll be positive, and we know it's the square root of 1 over the square root of 2. So x would be equal to 1 over the square root of 2. Now, we do not like to keep our square roots in the denominator. We want to rationalize the denominator. To do that, you're going to multiply by whatever the denominator is on the top and the bottom, because we can multiply by 1. 1 can be anything we need it to be, and in this case, we need it to be a square root of 2. So now we've got the square root of 2 over, and to multiply these, you get the square root of 2 times the square root of 2 is the square root of 4. Square root of 4 is 2, so it'll be the square root of 2 over 2. And with that, we know that because the x and y are the same, our point would be the square root of 2 over 2, the square root of 2 over 2. And that is the terminal point. That is right there. So that's how we can kind of figure out some other pieces and parts that are not just on the x and y axis. So there are some special terminal points that are determined and understood to be in those. And I have those drawn or printed on your unit circle on the handout. So there's particular ones. I'm going to actually draw them out, but this is how we can find all of the points on our unit circle by using our knowledge. Once we find quadrant 1, we can use our knowledge of signs to find the rest. Alrighty, so here is a basic chart. So we have T, and this would be the terminal point. These are ones you need to know. So we have 0, pi over 6, pi over 4, pi over 3, and pi over 2. These are the basic ones we will learn in this, and you need to know this. This is something, it's not about memorizing, it's about understanding. So at 0, that's where we're starting out. If t is equal to 0, it hasn't moved off of our circle. So that's the point right here. This is our t is equal to 0. So that point is going to be 1, 0. Pi over 6 will be the square root of 3 over 2, 1/2. Pi over 4, we just found that one. It's the square root of 2, square root of 2. Square root of 2 over 2, square root of 2 over 2. Pi over 3 will be 1/2 and the square root of 3 over 2. And then pi over 2, that's at the very top of our circle. And that's that y-intercept, so it will be 0, 1. Now what I want you to notice is these look very much alike, but they are slightly different. They're backwards from each other. So one of the ways that I try to remember which one is which is that it's pi over 3, so 3 comes second, so the 3 comes second in the point. So pi over 3 will be 1/2 square root of 3 over 2, but the pi over 6 is square root of 3 over 2 and 1/2. Because sometimes if we make little notes to ourselves of how it goes, it will be helpful. There are some mnemonics that you can use as far as how it plays about. You can look at that this is goes from 0 to 1 to 2 to 3, and then it's back to 1 because that would be like 4 over 4 kind of thing. This one is going from 0 to 1 to 2 to 3 this way. So you can look at that it's going up or that it's coming down as it goes around the circle. So that might be a little bit helpful, just paying attention to what lands where. And we'll learn those a little bit more about the sine and the cosines when we get into those. All right, so let's find a terminal point. So if we are given that t is equal to negative pi over 4, that tells us it's a negative number. So on our unit circle, we are going to be starting here, and it goes this way. Now, we know at pi over 4, this is our point. So we know that it's going to be the square root of 2 over 2, square root of 2 over 2. We are in quadrant 4, so that tells us that our y is negative. All right, let's look at another one. So t is equal to 3 pi over 4. Again, let's draw a circle because that picture can help you understand what we're doing. So 3 pi over 4, so that is 3/4 of the way around, right? So we're looking at, well, not 3/4 of the way around, 3/4 of the way around at the top. Because 4 pi over 4 would land us over here on the x-axis. So this is going to be 1 pi over 4, 2 pi over 4, 3 pi over 4. So we're going to land right over here. This one down here was 3 pi over 2, all the way down here. 3 pi over 4 is going to land you, it's less than a pi. Pi is halfway around, so we're going to land right there. So we still know that the value is square root of 2 over 2, square root of 2 over 2, but who's positive and who's negative? Well, we're in quadrant 2 here, so that means our x is negative and our y is going to be positive. All right, let's look at another one. We have t is equal to negative 5 pi over 6. So 5 pi over 6, that's almost one way around because 6 pi over 6 would get us 1 pi. So we are moving almost all the, I went the wrong way, didn't I? Because that's negative. Got to pay attention to those negatives. All righty. So let's pull a different color. So that would be the wrong direction. Always pay attention. All right, so we're going to go this way, and we're going to land about right here. It's a guesstimation. It's a sketch of a graph. Understand that this point for pi over 6 was square root of 3 over 2 and 1/2. But we are in quadrant 3, and both x and y are negative. So that will be our point right there. So this gets us into reference numbers. So for reference numbers, let t be a real number, and the reference number t bar, it's called t bar because it has a bar over the top, is associated with t. It's the shortest distance along the unit circle between the terminal point determined by t and the x-axis. So if we've got, we're looking at distances, so the distance of it will be t bar. So the distance of t will be equal to t bar no matter where we land, but it's the shortest distance. So in this case here, if our point comes to this point, this part here will be t bar because it's to the closest x-axis. So by t and the x-axis, the shortest distance. If our angle comes clear around to here, we're going back up to the x-axis, this will be the t bar right here. If our angle takes us most of the way around, its t bar is back up to this x-axis. So closest way to get to the x-axis is what you're looking for. So let's go look at some points and find the reference numbers. Alrighty, so if we are given that we're going to find, let's switch pages. We have a few of these, and that way we don't have to change it in the middle. So we're going to find the reference number for each value of t. So if we're looking at t is equal to 5 pi over 6, and we're looking at t is equal to that. So we almost did this earlier. This is positive, so we're going this way, and it will land right over here. So what we're looking for is the space that lands right there. That is going to be our t bar. So t is equal to 5 pi over 6. To find our t bar, so the t with a bar over the top, we need to find the distance. Well, we know that going around halfway around our unit circle is a full pi. So we know that we've got pi. And we want to subtract that 5 pi over 6. So how do we get our value? Well, if we're looking at needing a common denominator of 6, we can make this 6 pi over 6 minus 5 pi over 6, and that will leave us with 1 pi over 6. So that is our t bar and what it is equal to. So you're just looking at that distance, and if we're at 1 pi, we can just subtract it from it. All right, let's look at t is equal to 7 pi over 4. So if we're looking at 7 pi over 4, drawing around our unit circle. So 7 pi over 4, let's figure out where that's at. So this would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4 is almost all the way around. So it's going to land us right there. 7 pi over 4. You can also look at all the way around. Remember, it's 2 pi, so if you get a common denominator, it would be 8 pi over 4, which is what we need to know. We've got to find our t-bar again. So all the way around we know is 2 pi. That's our circumference around the whole circle because we're looking for that distance right here. Well, if we need a common denominator, we know our denominator would be 4 pi up here. Well, if it's 4 down here, doing that what we do to the bottom, remember that's over 1, so 4 times 1 would get us 4, so 4 times 2 would get us 8. If we reduce this down, 8 pi over 4 is going to be 2 pi. But I need that common denominator, so I can subtract 7 pi over 4 and get 1 pi over 4. So this is equal to our t-bar. That distance will be pi over 4. All right, let's look at another value. So we have t is equal to negative 2 pi over 3. So again, let's draw our unit circle to get us started. You don't always have to draw it, but it helps to see what you're trying to do here. Alrighty, so on this one, we're starting here. It's pi over 3. So that means this bottom part, we're going to the bottom because it's negative, is divided into thirds. So this would be 1/3, and this would be like 2/3. So we're landing about somewhere in there. You're just dividing it by 3 on the bottom. If it was a positive, you divide 3 up at the top because you're doing 1/3 of that pi. So this is where we land. So that means the distance up here, that is going to be our t-bar right there. T-bar is going to be the distance to the x-axis. So we're going again, we're looking for that t-bar value. Well, we know that clear over to that x would be, this would be pi, but we need to subtract that 2 pi over 3. So I need a common denominator of 3, so this becomes 3 pi over 3. And I know this is a negative 2 pi over 3, but we're still looking for the value of t-bar, just the distance. And the distance is positive. We don't have negative distance. So we're still going to subtract 2 pi over 3, and that will get us 1 pi over 3, and that would be our t-bar. All right, what if we have a t is equal to 5.80? Well, what does that mean? Because we've been dealing with pi's. Well, remember what pi is equal to. So pi, we know, there's a lot of things about pi day. Pi is equal to 3.14. That means the distance from here to here would be 3.14. All the way around, if we add another 3.14, we get 6.28. So we can understand that if fully around is 6.28, if we're going to 5.8, it's pretty close to that. Not quite there, but it's going to land us somewhere over here into quadrant 4. So that's our angle, and you could, again, you could take 6.28 divide, or 3.14 divide by 4, and add like, or divide by 2 to get a half of the pi, and you'll find out a little bit more where it lands. But in order to find our t-bar, we can do 6.28 minus 5.80. and we will get 4.8. And that again would be our t-bar. And what I was saying is we took 3.14 and we divided by 2 to figure out where this value would be down here. Let me figure out what that is. I don't have that in my notes. I think it'll be like 1.67, something like that. So 3.14 divided by 2, 1.57. 1.57. Yeah. And then we could add that to 3.14 and 4.71. That way you can understand a little clearly. This is 4.71. This would be 6.28. This is 3.14. And that way you can understand, this would be 1.57, why we land over here with that 5.80. Because as we cruise around, we're going to be somewhere between these two values here. All right. So let's go find a terminal point. So we're going to find the terminal point determined by the t. So if we are given t is equal to 5 pi over 6, we understand now that our reference number, and I'm pretty much going to do like a hashtag because that's what number meant back in our day. So we have t bar would be equal to pi over 6, right? Because we take 6 pi over 6 minus 5 pi over 6, and we got pi over 6. We already found that a little bit ago. We had the terminal point of 5, or the t equal to 5 pi over 6, and we found our t bar is equal to pi over 6. With that t bar takes us back to those terminal points that we discussed a little bit ago. We can use our terminal points here to figure out what's going on. So we have pi over 6, we know what the point looks like, and I left off one of my parentheses there. We know that the point, the terminal point, would be the square root of 3 over 2 and 1/2. But 5 pi over 6 lands us in quadrant 2. So in quadrant 2, we know that x is negative and y is positive. So for quadrant 2, it will be negative square root of 3 over 2 and 1/2. All right, let's go to the next one. So if we have t is equal to 7 pi over 4, which we also found, 7 pi over 4, we found that t bar was equal to pi over 4. So we know that t bar is equal to pi over 4. And with that pi over 4, we know that the reference point, or the terminal point, would be square root of 2 over 2, square root of 2 over 2, going back to our chart that we made. So this again is your terminal point. But we are landing for 7 pi over 4, we were landing in quadrant 4. And quadrant 4 tells us that x and y will both be negative. So because we're in quadrant 4, we know that it'll be negative square root of 2 over 2, negative square root of 2 over 2. For t is equal to negative 2 pi over 3, we know that we found that our t bar was equal to pi over 3. So t bar is equal to pi over 3, and through our chart, we know that our terminal point is going to be 1/2 square root of 3 over 2. And negative 2 pi over 3 landed us into quadrant 3. So because we're in quadrant 3, we know that they will both be negative. And I made a mistake up here. We were in quadrant 4. X is positive. Sorry about that. You're probably going, oh, it's wrong. That's positive. That's negative. Quadrant 3, both are negative. So sorry about that. So negative 1/2, negative square root of 3 over 2. So I always give partial credit because we make mistakes. So let's talk about that one real quick again. That one is in quadrant 4. Our x values are positive. Our y values are negative. Quadrant 3, they are both negative. So, sorry about that. All right, let's look at one more that we didn't already do. So we have t is equal to 29 pi over 6. So, we need to get this down to one that we know. Well, if we look at 29 and we divide it by 6, so let's do that. So 29 divided by 6, we get a 4.833333. So what we care is that 6 will go in there 4 times. So we know that if we're looking at our unit circle, when we're looking at our circle, and it doesn't matter which circle we look at, 4 pi, that'll take us, 2 pi goes all the way around, 2 pi goes all the way around. So we're already back here. We just need to find the distance that it still goes. So if we're looking at that, 4 times 6 will get us 24. So if we take 24 from 29, so 29 minus 24 would leave us with 5 left over. So we can say that this is 4 pi because that's how many pi we found. So it's twice around plus the 5 pi over 6. Because that's what would be left over. We'll go around twice and then we'll land at 5 pi over 6. So our t bar is just like at the top, is pi over 6. So the terminal point is going to be the square root of 3 over 2 and 1/2. But 5 pi over 6 landed us back in quadrant 2 again, because we'll go once around, twice around, that's the 4 pi, and then 5 pi over 6 lands us in quadrant 2. So that'll get us the point of negative square root of 3 over 2 and 1/2, because the x is negative and the y is positive.